Hello and welcome back. And in this video, we're going to be talking about insertion in linked lists. So basically, first we're going to look at how to insert a node into the empty linked list. Um, so basically, what we do is we have when inserting an element into an empty linked list, all you need to do is basically create a new node right here. So you can create you have created this new node with value 2 and next pointer is just nil, and your current head is pointing to nil because there's nothing in the linked list at this point. So you make that connection, basically pointing your new node to the current head, which is nil, and then you move your head from pointing nil to pointing to that new node. Okay, and these sequence is very important. So you first point your new node to the head, and then you take head and point to the new node. What it does basically, because these pointers are just memory addresses, it just basically takes those memory addresses and assign to these values. So head uh, is gonna be pointing, or memory address is gonna be pointing to this new node 2, and the next is gonna be pointing to the same memory address as head was pointing, which was nil. So that's how you actually start to create your new linked list. Okay, so hope that was clear. Like, the sequence, once again, is you create a new node, you point your new node dot next to the head, and then you take head and point it to the new node. Okay, and we're gonna take a look at in the lab, like, how it actually works out. But I just want to make sure, like, you understand conceptually. Okay. Next is inserting node at the beginning in the linked list. Okay. So when inserting a node at the beginning in the linked list is actually a constant time operation once again, because all you need to do is create your new node. And as you can see here, your head is pointing to 4 at the moment, and this is your current linked list. Okay. So you create your new node, and then you create a link basically between the next and the head with the current head. So next points to the current head, which is 4, and then you move your head to the new element, and this becomes your new linked list. So your head becomes 2, and all the rest of the elements stays the way they are in the linked list. Okay, so that's how you insert in the beginning, at the beginning in the linked list. Now, if you want to insert at the end of the linked list, then it's like this. So you have this linked list, and you create your new node, right? And you basically take your new node and point it to the last element, right? So last element points to the new node, and then new nodes next start to point at the nil. So this is how you can actually insert at the end. Now, we can obviously see this one. Time complexity for this one is going to be O of n, because this is going to be a sequential operation. Every single time you want to insert a new node in the element in the linked list at the end, you have to traverse the entire list to get to the end and then insert an element into there. Okay. So hope that was actually that was, like, clear in theory. Let's take a look at the example basically in the lab. So let's go ahead and go in the REPL. Now, one of the feature I wanted to talk about REPL was, like, you can create more than, like, just write just one file. You can actually create files. So if you don't have this file section open, go ahead and open it. Now we're gonna add. Now remember, main has to be there because main is going to be the execution point. And we're going to create a new class called node.swift. Okay. And this class is simply going to be our node that we have actually looked at. So we're going to create our node. Now this node is going to have two things, data and next. Next is going to be of type node, and data is going to be of type int. Now next is nil initially, like, if you're going to assign it as nil, nilable or optional, and we're going to write our init, and init is going to take data, as input for this node, and we're going to assign that data into self.data. Okay, and that's how our node class is going to look like. Okay, and next, as soon as we initialize the node, create an object for node. Next is going to be pointing to nil. That's what we want. Okay, let's add another file, and this one is going to be linked list. So linked list dot swift. Okay, and in linked list dot swift, basically, we're going to create another class, linked list. Okay, and first we're going to create our head, which is going to be node, and that's going to be optional. So that means like initially it's going to be nil. Then we're going to create a function insert. This is inserting at the beginning, right? And all we need to do is first create our new node, all right? And then we take our new node and say new node.next is equal to the head, whatever head currently there is, right? So you take the memory address of the head where head is pointing, assign it to the next. So next is going to point to the same memory address as head is pointing. And then you take your head and make new node, make it point to the new node. And that's how you're inserting at the beginning of the linked list. Now, if it is empty linked list, in that case, it's also going to work because your head is nil. So it's the same thing. Your next pointer is going to point to nil, and your head becomes the new element. Now, if you want to append, that's the operation that you do, basically inserting at the end of the linked list. This is where you have to do a tad bit work. You're gonna first check if the head is nil. If it is nil, that means like the linked list is empty. So you say just call the insert and supply data, and we're gonna return from here. Okay. So basically, it's gonna do the same thing, same operation as insert. And then, if it's not the case, then we're going to create a variable called current, and you're going to put heads value in there. Now we're going to loop and say while current is, is and we're going to unforce unwrap it because we know current value is there because head has at least one value now because it would if the empty was if the list was empty, then we would have inserted like that value right here. Okay, so that means we know that there is something in there. So we're gonna check for the next item. So we say like current dot next is nil. Loop until that time until current dot next is nil, and assign uh, current dot next into the current. Okay, this way we're gonna loop through to traverse the list to reach the end of the linked list. Okay, the last element of the linked list whose next is pointing to the nil. Once we reach at that point, we're gonna create our new node, and we're gonna say sorry data, and here we're gonna say current dot next is equal to new node. Okay, and that's about it. So this is how we're gonna insert at the end. Now, all this operation is not, all these things are not gonna be fruitful if we can't see what's in the linked list. So let's go ahead and create a print function. So we're gonna say print list, and this is where we're gonna print our list. All right. So the way we're gonna print our list is we're gonna employ the same technique as current is equal to head, and this time we're gonna say current while current is not equal to nil, loop until that time. So sorry, this should be not equal to nil. So loop until this is not nil. So that's what we want. And here we're gonna do the same thing. We're gonna say print current dot data. So we simply gonna print the data, and we're gonna say take current and put current dot next into the current so we can get to the next item. Okay. Now this is all we need to do. Now let's go ahead and jump onto our main program and create our list, linked list. and we're gonna say list dot first list dot insert 10, and I'm gonna copy that 9, 8, 7, 6. Okay, and we're gonna print that dot. Okay, so if you run this, we should see. Okay, so we are missing data, system label. There we go. All right, so this is what we have. We have 6, 7, 8, 9, 10. Now, these are 6, 7, 8, 9, 10 because we are always inserting um, at the beginning. Okay. Now, if you wanna insert at the end, then you say list dot append, and you can append 11 there, and print list once again. And there we go. So we have initially we had 6, 7, 8, 9, 10. Then we had 6, 7, 8, 9, 10, 11. So as you can see, our insert at the beginning and insert at the end is working fine, and our print is also working fine. All right. So this is how you insert and print a list. In the next videos, we can actually also look at how to basically delete an item and search an item in the list. Okay, so that's what in the upcoming videos. So stay tuned, and I will see you guys in the next video. Thank you.